Now let's study about the different forms of equations, that is the diametric and parametric form. Diametric equation is a general equation, but parametric equation is a general equation which specifies each and every point. You are going to use parametric equations at many places when you want to find out the general coordinate of any point. So let's begin.
Now let's understand that what are the different forms of equation of circle. So the first special form or different form of equation of circle is the diametric form of equation of circle. Here you can see that there is a circle and there are 2 points x1 y1 and x2 y2. These are the coordinates of end points of the diameter. That means x1 y1 and x2 y2, if you join these 2 points, then this line is a diameter. So that is known as diametric form of equation of circle. If you know the endpoints of diameter, then the equation of circle in diametric form, you can write it as x minus x1 into x minus x2 plus y minus y1 into y minus y2 is equals to 0. That means you have used only the coordinates of endpoints of diameter and you have devised the equation of circle. You can multiply the brackets, you can open them, and you will get the 2-degree equation, which you can comparison with the general equation, you will form that it's the circle. Now this equation, again, as I have told you, that when you open the brackets, you will get x square plus y square, then these two terms, and then this term is a constant term. If you put y terms ahead, or if you keep aside y terms, then you can see that the x terms are forming a quadratic equation whose roots are x1 and x2. This is a special thing to note about. If you know any diametric form of equation, or if you can convert it into the diametric form, then x1, x2 are roots. So if this equation is somehow not easily resolvable into factors, then you can use the formula of finding out the roots, and the 2 coordinates that you are going to get are the coordinates of endpoints of diameter. That means the x coordinates. Similarly, the ordinate or the y coordinates can be found out by taking only the y terms and putting them equal to 0. So again, this is also a quadratic equation. So if you solve this quadratic equation, you will get 2 roots, and those 2 points will be the ordinate or y coordinates of diameter. So this is the diametric form of equation of circle. One more form of equation of circle is parametric equation of a circle. Now parametric equation, that means that we are devising a parameter to locate each and every point that lies on the curve. So for example, if this is a circle, then look what we are doing here. If x1, y1 are the coordinates of center, then obviously this point, any point P which is lying on the circumference, it will be at a distance r according to the condition, but we want to express these points. That what are these points? So let's say that I take an angle theta with the horizontal, and I say that xy is present at a theta angle from horizontal and at a r distance from x1, y1. So you have the theta, that is the slope of this line PC, and C is the center, and you have the point. So by using the concept of straight line, we can say that x minus x1 upon cos theta is equals to y minus y1 upon sin theta is equals to r. Okay, so you have to distinguish it carefully with the equation of line. Now when you try to find out the values of x and y, you will get as x is equals to x1 plus r cos theta and y is equals to y1 plus r sin theta, where x1 y1 are your centers. So that means that I can put any value of theta and I will get one of the coordinate. I can put any value of theta and I'll get these coordinates. Now what is the values of theta that I can put? I can put any value of theta from 0 to 2 pi, and each and every value of theta will give me a different coordinate. So by fluctuating or by varying the values of theta, I will get each and every coordinate that is lying on the circle. So parametric equation is very useful when you need to assume any point on the circle, because these r cos theta and r sin theta, they can be eliminated very easily. So if someone is asking you to find the locus or anything like this, you are always going to assume the coordinates in parametric form, because they are easily resolvable. You can eliminate easily this parameter and you can get the equation by squaring and adding. Okay, so this is the parametric equation of circle. Now let's check a concept. So the question here says that find the center and radius of this circle Okay, and find two general coordinates which differ by a right angle on the circumference. They differ by a right angle on the circumference. That means suppose if this is the circle, okay, and if this is one of the point, then this point and this point differ by an angle of pi by 2. That means you have to point another point like this so that this angle is pi by 2. Suppose if the parametric coordinate of this point is theta, it means the parametric coordinate of this point is going to be theta plus pi by 2. But let's first find out the radius and circle. If I multiply this whole equation, what I'm going to get is that x is square minus 7x plus 10 plus y square minus 6y plus 5 equals to 0. That means x is square plus y square minus 7x minus 6y plus 15 is equals to 0. Now what are your coordinate of center? Minus g comma minus f. That means minus 7 by 2 comma plus 7 by 2 comma 3. This is your center. What is your radius? Radius root of 49 by 4 g square plus f square minus c. That means root of 49 by 4 minus 6. That means you will get root of 25 by 4, or your radius is 5 by 2. Obviously radius has to be plus, so you don't have to write plus minus. Okay, it's 5 by 2. Radius is 5 by 2. Now we know the radius, we know the center. This coordinate theta, or let's say this point P will be given by x coordinate of point P will be x1, that is the x coordinate of center, plus r, that is radius, cos theta. Y coordinate of this point will be again y1 plus r, that is 5 by 2 sin theta. x1 plus r cos theta, y1 plus r sin theta. Now if this point is q, then point q will be 7 by 2. I don't have to do anything. The points differ by parametric angle pi by 2. My angle will change, cos theta plus pi by 2, comma 3 plus 5 by 2 sine of theta plus pi by 2. Okay, so this is how you write the parametric coordinates, cos of theta plus pi by 2 and sine of theta plus pi by 2. Now if you want to write these things, then I can also write point Q as 7 by 2. Now cos in second quadrant is negative and theta plus pi by 2 is a switch case, so 5 by 2 sin theta. Similarly 3 plus 5 by 2, now again sin theta is switch, so cos, but sin is positive, so it will remain positive here, and cos theta. These are the two parametric coordinates P and Q who will always differ by an angle pi by 2. So in this way you need to solve this question, and the parametric difference, I hope that it is clearly understood by this question.
So this is it about the diametric and parametric forms of the equation. I hope that you have understood. In the next part, we are going to start with the finding out what is a position of line and position of a point with respect to circle, and what are their different cases. Stay tuned with Ask IITians.